Hello everyone, and welcome back to the shop. In this short video, we are going to explore this RC servo from an engineer's perspective. The first step is to take it apart. This allows us to see the gear train, the DC motor, the controller printed circuit board, and one of the more important elements is this variable resistor, which serves as the feedback element. Most of our RC servos are able to rotate through 180 degrees. Here we see the shaft output, the final reduction gear, and the variable resistor. This variable resistor also rotates through 180 degrees. The resistor is shown on the right-hand side of the schematic. The dashed line represents our gear train connecting to the motor. The output of the resistor goes back to the controller where it's labeled feedback. For this older high-tech servo, this is the controller integrated circuit. Its whole purpose in life is to monitor the command signal which is coming in on this yellow wire, compare it to the variable feedback resistor, and move the motor so that the feedback, which is to say the output, is where it's commanded to be via the pulse width modulated input signal. As for the H-bridge, I believe that is composed of these 4 transistors, which are located in a row here. And they allow the motor to operate in a clockwise or counterclockwise direction. This RC servo has many of the characteristics of the traditional proportional, integral, derivative controller, which we shorten to PID controller. It has a sensing element which detects where we are, a controller. The controller compares where we are to where we should be, which is coming in on our yellow PWM wire. The controller then commands the motor to move. It does so even if we add a load to the motor. For example, if you try to force the servo gently clockwise, it will respond with a counterclockwise torque and vice versa. As we conclude, we should mention that most of these RC servos are terminated into this 0.1 inch header, where there are 3 wires. Black is ground, red is the supply, which is typically between 4.8-ish and 6 volts, and yellow is the command signal. That's the pulse width modulated signal that tells the servo where it is supposed to be.